विद्यार्थी मित्रांनो, आपण सॉलिड स्टेट युनिट स्टार्ट केलेलं आहे. तर आत्तापर्यंत हा जो पॉईंट आहे क्युबिक सिस्टम, त्यापर्यंत आपण कोणते पॉईंट्स डिस्कस केलेले आहे ते थोडक्यात पाहूया. सो स्टार्टिंग विथ जस्ट इंट्रोडक्शन फॉर सॉलिड स्टेट, that in that we just consider three states of matter: solid, liquid and gases. Then next one, types of solids. First one crystalline, second one amorphous, some properties of regularity, periodicity, about melting points, then anisotropy of crystalline solids. An example. The next one, amorphous solids, some properties with arrangement of particles, also its melting point, then isotropic properties, and simply examples of amorphous. The next term related to solid state: isomorphism and polymorphism. What is isomorphism, what is polymorphism, and at least one example of each. Then next one, classification of crystalline solids. There are four types of crystalline. First one, ionic crystal, second covalent network crystals, molecular crystals, and metallic crystal, with some properties of this one and at least one example of each type of crystal. The next one, comparison between these four according to properties of these four types: the ionic crystal, covalent, second one, the third one molecular, and fourth one metallic crystals. Now next one, unit cell. That is the basic portion of any substance or solid. Unit cell in crystalline structure. The next one, types of unit cell. That is primitive or simple unit cell, body centered unit cell, and third one, face centered. First one, primitive or simple, SC. Second, body centered, BCC, and third one, FCC. The next one, crystal system. That is particularly Bravais lattice, which are depending on the different arrangement of particles or spacing between 2 points and axis and angles through different axes, that is alpha, beta, and gamma. Depending on the variation of these parameters, there are present at least there are total 14 lattices present and main 7. So just a simple, and what are the parameters? That is spacing between 2 points, that is distances between 2 points, and angles between these axes, that is alpha, beta, gamma. What are the conditions for this different types of Bravais lattices? That is total 14 lattices. Then we see next point, cubic system. Simply three types: simple, cubic, body centered, and FCC. And next point, number of particles present in cubic cell. That is first one of primitive. There are how many particles are contributed to the main crystal structure. That is one particle per unit cell in simple cubic. The next two particles per BCC unit cell in body centered cubic unit cell main structure, and third one, face centered. For face centered, there are total 4 particles per unit cell, which is contributed to the main crystal structure. Now students, we move to the next half part of this one. It is the relationship between molar mass, density of the substance. Molar mass, density of the substance, and unit cell age length. That is how they are related with each other. त्याच्यामध्ये जे रिलेशनशिप असेल, मोलर मास कॅपिटल M, डेन्सिटी रो, आणि त्याचे जे युनिट सेलची जी एज लेंथ असेल, विच इज डिनोटेड बाय सिम्पली A, small a. So what is the relation between these three parameters? So simply see on your screen, or it is given on page number 8 in your book. So starting First step, the different steps are used here to deduce the relationship between molar mass, density of the substance, and units age, unit cell age length A. So first, if age length of cubic unit cell is A small a, the volume of unit cell is 3 times of length, that is A cube. A into A, that is A cube. Suppose, second step, suppose that the mass of one particle is m, small m, and there are n number of particles per unit cell. So mass of unit cell is equal to, it is mass of one particle into number of particles, that is m into n. This is the equation number 1.1. Now the density rho of unit cell, which is the same as the density of substance by simple formula, that is it is mass upon volume. So here consider the density for unit cell. So here rho of unit cell, that is density of unit cell, rho equal to mass of unit cell upon its volume, or simply volume of unit cell, that is mass. How it is calculated in equation 1.1, that is mass of unit cell equal to m into n divided by A cube, that is the density of the substance, or say unit cell. This is the equation 1.2. Now next one, molar mass, capital M of the substance is given by, and the mass of one particle into number of particles per mole, that is Avogadro's number, that is 6.023 into 10 raised to 23. That is mass of one particle, small m, into Avogadro's number, Na. Therefore small m, mass of one particle equal to m, capital M divided by Na. This is equation 1.3. If we combine the equation 1.1 and 1.3, that is the rho equal to, put the value of m, that is capital M by Na into n upon A cube. This is the equation 1. And this give the relationship between molar mass, that is capital M, density of the substance rho, and the unit cell length A, and we can calculate the different, or if we know the different parameters, then we calculate at least one parameter from this equation. That is, if there are 5 parameters in this equation, if we know that any 4 parameters, then we calculate the remaining one. So simple, this is the relationship between molar mass, density of the substance, and unit cell age length. This is asked for 2 marks in your examination. Now student, there is one problem based on this relationship. That is problem number 1.1. See, when gold crystallizes, it forms face-centered cubic cells, that is the FCC structure. The unit cell length is 408 pm, picometer. It is the small unit for calculation of or measuring the distance between 2 points, picometers. Next one, calculate the density of gold, and given data is molar mass for gold is 197 gram per mole. So what is the solution? Is the formula of density rho equal to capital M into N divided by A cube into Na, that is Avogadro's number. So write down given data, M is equal to 197 gram to mole inverse, or per mole, molar mass of gold. Next one, N, here how it is, N is calculated. So we can calculate, we just calculate number of particles present per unit cell in given crystal structure. For cubic it is 1 particle, for a simple cubic. Then for body center cubic, there are 2 particles per unit cell, and there are 4 particles or say atoms, ions or molecules, what it may be. It is colder, so the basic particle is atom. So for FCC unit cell, there are 4 particles which is per unit cell, which is contributed to the main crystal structure. So N is equal to small n is 4 atoms for FCC. Next one is Avogadro's number. It is standard value 6.022 into 10 raised to 23 atoms per mole. A, the age length is equal to 408 pm, that is 408 into 10 raised to minus 12 meter, or 4.08 into 10 raised to minus 8 centimeter. Next one, put the values of given parameters in equation or say formula. So rho is equal to 197 gram per mole into atom divided by 4.08 into 10 raised to minus 8 cubic centimeter raised to 3 into 6.022 into 10 raised to 23 atom per mole, or atom into mole inverse. So cancel the same terms, and by solving this one we get the final answer, that is 19.27 gram per cubic centimeter, or in kilogram 19.27 into 10 raised to 3 kilogram per cubic meter. This is the answer. So student, this is the part up to the cubic system. Now remaining will be 3 to 4 points of this solid state. Next one, packing of particles in crystal lattice, that is what is closed packed structure. In that, square closed packing, hexagonal closed packing, and it is in 3D structure. Next point, packing. Then number of voids, just the concept of voids or coordination numbers in a closed packed structure. Next one, voids 1.6. Next one, 1.7 is packing efficiency. What is packing efficiency, how it is calculated. Then for simple cubic, for BCC, and for FCC, how it is calculated, packing efficiency. And there are some concept about number of particles and unit cell in x gram of metallic crystal, an example based on it. And next one, 1.8, crystal defects of what are imperfections, that is point defects, stoichiometric point defects, vacancy defect, self interstitial defects, Schottky defects. These are the points. Next one, Frankel defects. So these are the different types of defects which are considered or just seen in crystal defects or imperfections, different types. So up to 1.8 the syllabus for solid state, and the last 2 points from 1.8, that is electrical properties of solid and magnetic properties, they are dropped for examination. So up to 1.8, just see up to 1.4 we just clear, study all the points from book. Now there are remaining points will be 1.6, 1.7 and 1.8. So students, thank you for joining the lecture.